In this lesson, we're going to talk about 30, 60, 90 triangles. I'm going to use the multiple proportion method. Some of you may have learned the method where you label this side as A, and this side is A, and this side is A root 2. Your teacher might have used an X, and I actually have another video about that if you want to watch that. But in this way, we're going to use a proportional method. We still are going to call the leg, A, but we're going to use the number 1, and the hypotenuse is root 2, and keep in mind that both legs are the same. So what this means is if I set up a proportion of the three sides, okay, and I say that the first one is 1, corresponding to the first 45 degree angle, and that would make the second one also a 1, corresponding to the second 45 degree angle. And then the hypotenuse, which corresponds to the 90-degree angle, would be root 2. If you want to know where these come from, if you use the Pythagorean theorem, a squared plus b squared equals c squared, you can see that 1 plus 1 would be 2, and then you take the square root. So you can see how this would all tie together with the Pythagorean theorem. So knowing that, what we would do now is we would go and search for the side across from these angles. So the first one, the first 45-degree angle would be 25. So I would put 25 there. The second 45-degree angle, using the sum of all of the inside angles of a triangle, would be 180. This would be 45 and 90. That would make this one 45. And so that one would come out, as you can see, that 45 would make that one what I put there. And the last one across from the 90 is what I would put there. So what I'm saying to you here is that this triangle becomes a proportion corresponding to the side value, which is a ratio of 1 to 1 for the 45-degree isosceles triangle. And so across from the 45, I wouldn't use the 45. I would use what's across from it, the side length 25. And then this one would be not the 45. I would want to use the y. And for the 90, I would not want to use 90. I would want to use what's across from it, or x. And now I have three proportions that will very easily tell me the value of these sides. So for instance, this one right here, it's just very clear if I look at this one right here, that y equals 25. I could even cross multiply this one, right? And that would give me y, right? 1y for this, 1 times y. And that would equal 1 times 25. And so I could also just look at this and visually inspect that y equals 25. Now, once I know that, I see that I have the equal proportion, 125 equals 125. And then I would use that proportion to then solve for the other part. So what do I mean by that? Well, effectively, if I need to, I can actually skip this middle one right here and set 125 equal to 2 over root x. Again, I could just skip the middle one, and you can do that at any time. If I wanted to solve for x, because I like to alphabetize my math, I could have skipped to 1 over 25 is equal to root 2 over x. And then I solve that by cross multiplication, which would give me 1x equals 25 root 1x equals 25 root 2. So that is a different method than maybe you've seen. Again, if you like that A method, there is another video to do it that way. They're both valid. I'm just using this method as well, so students have another way of doing it. Let's take a look at one more example of that, and then we'll do 30, 60, 90. So here is the triple proportion, 1, 1, root 2, giving the proportion of the sides that correspond to the 45, 45, and 90-degree angles. Now, across from these, again, this one's 45, so that one's 45 due to the sum of the interior angles of a triangle equaling 180. So I would go, okay, well, 45 is going to be below that ratio. I'm going to put x, right? And below this 45, I'm going to put y. And below the 90-degree ratio, I'm going to put 19. So let's just see what happens. I think some of you might think this is really reasonable. So across from the 45, I put x. Across from the this 45, I put y. So this is telling you that y and x are the same. Once we know one, we have the other. And across from the 90, we put 19. The only thing I've ever seen students do is when they're doing this, and they go 45 is x. Here, they'll accidentally put the angle. So when you're doing this, y is 45. Make sure you're putting the side. And when you do this, make sure you put the side. And if you need to, every student is different. My recommendation would be to cross these out. And if you have them color coded like I have, you can clearly see that those should match. So which one should we solve? Let's just go alphabetically to reiterate. Like I can skip over this proportion right here and just do that one. 1 over x is equal to root 2 over 19. So let's take a look at that. So 1 over x is equal to root 2 over 19. I'm going to cross multiply. So if I cross multiply that, that would give me x root 2 is equal to 19. Then I would have to divide, and then I encounter some mathematical grammar, right? This will cancel. This doesn't cancel. So I have to rationalize that by simply multiplying by root 2 on the top and the bottom. Now, when I do that, I have to remember what that means, okay? On the top, we get an unreducible 19 root 2. And on the bottom, we get 2, not because the square roots cancel. They actually combine, so I wouldn't want to say cancel. But the real reason is because I actually get the square root of 4, right? Because 2 times 2 is 4, and that would reduce to 2. So if that is x, you can see by the proportion, that's why this proportion method is so handy. You can see that x is equal to y, so you know that they're equal to each other. Now, similarly, you can also do this with a 30, 60, 90. You might have learned it that across from the 90 you have a, and across from the 60 you have a root 3, and across from the 90 you have 2a. But we're going to go with the proportion of the shorter leg, meaning the one across from the 90 is 1. The longer leg, which sometimes I call middle leg, just depends on your teacher. So if your teacher wants to call it that, that's fine. I typically call it maybe the middle one. It's actually the square root of 3. And the reason that is the middle value is because the square root of 3 is 1.7. So if the hypotenuse is 2, 1.7 is between 1 and 2. So using that proportion, let's see how this works out. So we have 1, root 3, and 2. This one corresponds to the 30, the 60, and the 90. And then we're going to just do the same thing we did a little bit ago. So across from the 30, and again, same reason, right? So in this one, if this is 90, this is 60, this has to be 30 because the sum has to be 180. So once we know that, and we look at that, that 30, across from that is a 5. The 5 will go there because it all corresponds together. And across from the 60 is an x, so the x will go there. And then across from the 90 is a y, so the y will go there. Again, if the angles confuse you, scratch them out. Okay, so if you don't want to see these, once you have done that, it becomes pretty easy. This is 5, this is x, and this is y. So which one will we solve? It's up to you. Some students will want to do this alphabetically. My brain likes the fact that 1/5 and 2 over y is a nice non-radical problem. So I'm going to do that. I'll do 1/5 equals 2 over y. Very easy to solve that. Some of you already know it's 10 because your brain is looking at the proportion and realizing that it would be 2 over 10. But if you need to solve it, you would get 1y equals 10. And I just want you to look at the beauty of that. Like knowing that this is equal to 10 means if I put a 10 here, this will reduce to 1/5. And proportions, that's how they work. Everything must equal each other. All right, so now that I've solved that, maybe I'll solve this one. 1/5 is equal to root 3 over x. And if I cross multiply that, I get 1x is equal to 5 root 3. And so that's what that one equals, 5 root 3. Please keep in mind, it's always integer in front of the radical, and you don't ever multiply them together and get like root 15. In order to multiply a radical, you'd have to have two radicals, like the square root of 3 times the square root of 2 would be the square root of 6. But 2 times the square root of 3 is just the square root of 3. And vice versa, if I did the square root of 3 times 2, that would also be 2 square root of 3. But just remember your radical rules as you're doing this. It's actually, in my opinion, the hardest part of this is the radical rules. So let's take a look at this one. Again, I know this is a 30, 60, 90 because 30 and 90 would leave 60 right here. That gives me this proportion of 1 root 3 and 2, this being the 30, this being the 60, this being the 90. Then I'm just going to figure out where everything is. The setup is the most important part. So across from the 30, I would have x. Across from the 30, I would have x. Across from the 60, I would have y. And across from the 90, I'd have 32. That methodical going in order Maybe if you need to, again, crossing these out so you don't accidentally write them down, that's the way to be successful. So this one would be X, this one would be Y, and this one would be 32. Just so I can color code that. Again, just to review, 30 would X, so that one would be X. 60 would be Y, so that one would be Y. And then 90 would be 32. And if you do it that way, it's always going to work that way. Now, one of the things I want to show you that's super helpful is you could just go ahead. You can't ever solve for two variables. So in this case, you would never want to solve this because you have an X and a Y. But you could just cross multiply this and solve. But I'm going to show you something super helpful. Isn't 2 30-seconds reducible? Meaning, isn't it just 1/16? Cross multiply that instead. And the reason is you will get the same answer, but if you reduce the proportion before you cross multiply it, you will have less work at the end of the problem. So this would just give me y equals 16 root 3. Now, if I did this, I just want you to think about it. This would be 2y is equal to 32 root 3. Then I would have to divide by 2, and I would get 16 root 3. But doing it the way I showed you by reducing first makes the problem much easier. It also makes this part of the problem easier. So let me put this in here, 16 root 3. If I were to erase this and I reduce this proportion, doesn't it just say that x equals 16? So I already know that that's equal to 16. Now, again, the beauty of this is you can't really go wrong. So if you did 1 over x is equal to 2 over 32 and you ignored everything I said, you would still get the answer, right? Because you would get 2x equals 32, and then you would divide by 2 and get 16. But you can see that by starting the problem and asking yourself, do any of these reduce? And if they do reduce them, it does make your life easier. All right, so just to review, we did an alternative way to do a 45, 45, 90 triangle by using the proportion of 1 to 1 to root 2, using cross multiplication and ratios. We did the same thing with 30, 60, 90 using the proportion of 1 root 3 to 2. The hardest part of it is dealing with radicals. And also the most important thing to remember is also to try to reduce anything that you can, including radicals, before you begin the problem. All right, in my next video, I'll do some extra examples.